to determine that. And you might want to think, okay, well, what do I use this for? Think of this building. Maybe it was multi-floor, and we're trying to run a sewer line from that floor to this floor, and we've got to get over to this place. How do we know where we're going to take it? Where is it going to intersect? Is it going to come through the joist up above? Is it going to go through the trusses? Is it going to intersect a wall? And if it is, where do we have to cut that wall to get this through? In essence, it's determining the location of items in space. That's intersections. The other part is visibility, and it goes right along with intersections. Visibility is establishing which things are closer to you in a multi-view drawing. And you're probably aware now when you look at a multi-view and you see a couple lines, you need an adjacent view to determine if one plane's in front of the other one. Okay? And that's in essence what we'll do with that. So we'll establish the geometric location of items with visibility. Tomorrow, we're then going to go into a different drawing type, which is called a development. A development is, in essence, taking a three-dimensional shape and transforming it to a two-dimensional medium. Okay, think of ductwork here, or we've got that big wing out on our parking lot for a, what do you call those things, a windmill? Okay. Well, they use developments to build those. In the drawing types that go in. We actually have a real big company in here that does nothing but drawing types. It used to be called Solo Cal. What's it called now? I can't remember. Somebody bought Solo. What's that?
Dart.
Dart? Might be. Yeah. Somebody bought them out a couple of years ago. Jim, I think the other day when we went into his lab, referenced that. So developments are the process of taking a three-dimensional shape and transforming it to a two-dimensional medium. So for today, let's talk about intersections and visibility. And there are a couple techniques. Now, I guess I probably ought to talk while I'm doing this. Here's a kind of a drawing that you would need for intersections and visibility. This is, I'm guessing, it says it's a petrochemical plant. This looks a lot like our plant in Salt Lake where they take it, make gas and send it around the western United States.
Oh, yeah.
If you've driven to the south side of Salt Lake, you'll see this. It goes for quite a few acres. But when you look at a facility like this, I mean, what's the thing made of? See a lot of pipes, don't you? Mm-hmm. That's in essence the entire thing. It's pumps and pipes and tanks. Now, when we get these pipes on a drawing, you can kind of see in here, there's a whole bunch of these pipes in here. We look at them from a certain view, all you see is a bunch of lines, and how do you know where these pipes go? In essence, we have to do elevations or front views. We've got to do side views, top views, and determine where these go. Okay, so that's an example of what we would use visibility for. They give you another one right up above in the top right where you see three pipes coming by some other big storage pipes. And certainly when we're running these pipes for a plant industry, we probably can't have it hitting into this big white tank here, or the yellow tank, whatever color that is. So we've got to kind of plan that out, because this stuff's not cheap. And when we're running it, and we get on the job site and we're starting to run this through, and all of a sudden, hey, there's a big thing in our way, something should have happened beforehand to determine if that was going to happen or not, and that would have been our job. Okay, so that would be a fall in. They give you, on 15.3, this is an example of a development where we have a warped surface like these wings. We do 2D drawings of those, but we'll get more into that tomorrow. So let's look at the process. So page 718. This is establishing visibility, or which items are closer to us. And keep in mind, there's nothing new on projection here than what we've talked about before. You just have to have two views to establish visibility. So if you look at these two, okay, this is front view, top view. Got a couple pipes that are intersecting, or we think they're intersecting, we don't really know. Okay. What we got to determine is which one of these is an AB or LG that's on top of the other one. Because if we can establish the height medium, then we can find out if they're going to intersect. Okay, because we're given basically width, height here, we're given depth and width on this view. Now, the way you do it is you concentrate on one view. So in this one, let's look at just the top view. Which one is closer to us as we go through that? Let me grab a pencil. I don't want to write in my book. A pen. So the way you establish this, another pen, is we look at one view. Now, if I look at this, I see that AB and LH, if they're going to intersect, they will intersect right there. Is that correct? You kind of see that?
Yeah.
Now, do they intersect there? We don't really know. Not from one view. We also don't know if AB goes over the top of LG or if LG goes over the top of AB. The way we can find that out is we just take this point that is a supposed intersection and we project it to any adjacent view. So in essence, I take that intersection, I'm going to follow that red line the author's got on there and draw that line down to my other view. Now as you come into the other view, notice that I hit this pipe first, AB. Therefore, what that is telling me, since I always hit AB first on this orientation, that AB right here is on top. So AB is on top of LG in this view. Now you might relate that back to orthographic projection, and I always said, when we were numbering 1, 2, 3, 4 last week, okay, and I always said, hey, you go to one view, the closest one to you is always going to be there because I'm always taking this thing and rotating it 90. So if I've got this that's close to a fold plane and I rotate it to a top, notice it's got to be the one closest to me, right? When we took those single lines or lines to find planes, and if we rotate them, no matter what view, so I'm sitting on here, this side's closer to this fold plane. So as I rotate to a right side view, what point has to be close to me? This one. Okay. In essence, we're just using that same concept here. So I look at the intersection, project it down, I hit AB first. In this view, AB is on top of LG. LG is underneath it. Now, how far underneath it? Well, we've got the distance right there. That's how far at that location that it is underneath. Now, I say that and I say, well, that's somewhat subjective because we don't know true length, right? And you got to get to true length before you really know straight line distances or point views, one of the two. See? So that's on the bottom view, or the top view. Now, you don't know really what's going on here, but you do the same thing. So on this one, which one's on top or whatever in this view, again, look at the supposed intersection point, this one right here. And then I'm going to project that into this view, and as I bring that up, notice you hit LG first, right here. So therefore, on this intersection, LG is on top of AB. So now we can start getting a little bit of an idea of how this works. Where here, I know AB's on top, I rotate it back in, LG now is sitting on top. So you can start visualizing how these things are working. In essence, you're using an intersection point or supposed intersection point to establish which one's on top in the view you're looking at. Now, the only thing that's a little different than this than we've done all along is we've always projected into a view and then built on this view and went to another one, right? What you got to remember is I'm trying to establish visibility in this view, and I project to an adjacent view to establish that. So all I do is look here, which one do I hit first? Has to be on top. Come here, look here, which one do I hit first? Has to be on top in this situation. So in essence, for pipe drawings or other things like that, that would establish that. If you turn to 719, here's an example the author's giving you. It's really a little more real life where you're showing the three-dimensional piping. You can kind of see how they get about the process. In the front view, we would then look at the supposed intersection and then project that back in. Is it LG or is it AB? Which pipe's on top here? Project in, I hit LG first. So in this view, LG's on top. And they kind of came in on the end view and drew that in. When I come to this view, project it down, I hit AB first, it's on top in this view, and you can kind of see the same setup over there. So it's a way for us to really kind of start visualizing the depth or missing dimension from these views. Now you can take this one step further, and we can start bringing planes into it. Well, before I get into that, I better mention this figure. Let's go to 720, figure 15.7. Sometimes we do want things to clash and hit. And this is also a way to establish that. On this one, notice here, they looked at the supposed intersection. They said, which one's on top? Is it A, B, or C, D? They projected up, they hit the point of intersection. Well, if I'm hitting the point of intersection in both of these, they now meet at that point, right? Because I'm not hitting one before the other. So the height difference hasn't changed. And many times we do that because we want to hit it. Again, think of a sewer line for a building like this. I mean, we've got our sink back here. We've got the restrooms down there. There's a bunch of water over here. All that's going into one line. It's all dropping from its place into what we call a trunk line that's going to carry everything out to a central point. In that case, we need to join that line with this one over here. So now we're looking for pipes that clash so that we can put T's in them, join them together and mix the flows up or whatever the case might be. So the one change, keep in mind, if you take a point of intersection, project it into an adjacent, you hit another intersection, they're hitting at that point. So they're intersecting. And that's a way to establish that. Now the other part of this is when you get to planes. Because a lot of times we don't have pipes to pipes, we have pipes to planes and planes to pipes. It's the opposite. When you are doing a plane, what you first do is have to get to the edge view of the plane. Okay? And that's in essence what they're doing here. So you've got your views, we've got a pipe and a plane, okay? Front top. They came over here, they drew a strike line on the plane. Remember why we drew strike lines? That's applying law 1. So they drew a parallel, projected up into here. I know that line's true length. Then they rotated for law 2 to get edge view of the plane, which is right here. Now they're still carrying the pipe. So here's our supposed intersection, right here. If they're going to meet, it's going to meet on that point. So notice what they then do is they then take that point back and they take it out. Now if you hit this pipe outside of the plane, so in this case it looks to me like it hits a little outside, that pipe doesn't intersect that plane at all. If it hits anywhere inside the plane, that's where the pierce point is or where that pipe goes through the plane. But we've got to turn it on edge to get this point before we can project it back and determine if it hits this plane or not on its current trajectory. So in essence, that is using it for a plane. Turn the planes on edge and project them back. Now, I'm only going to do one day on this type of stuff because this type of drawing method is starting to go away a little bit with the advent of three-dimensional drafting. Because now what we're doing is we got programs where we can do our pipes three-dimensional, not two-dimensional. We build the entire database or plant three-dimensional. And so if we want to see if things interject, all we do is get on the pipe in our view and follow the pipe down it and then see it. There are still companies that do 2D though. So I think it's worth at least one day to expose you to this a little bit, give you a little bit of practice of it. Maybe you go to work for one of these firms, you go, oh, I did that at one point. You remember where it's at in the text, and you can go ahead and reteach yourself at that point what's going on. Are you going to be doing this with a large company? Probably not. Okay? It would be a smaller firm that didn't have the resources to produce the software and things and the personnel to draw these things up three-dimensional. Okay? So, in essence, that's the process. Any questions on it? Okay. I want to give you just a little bit of practice on this, and I do have one copy I put on this that I need to go over. before I go to this, as you're looking through the text to back these up, one thing I want to point out, as you work through these worksheets and you're coming to the text to see the techniques, stick with the edge view method here. This is like the previous chapter where we had the auxiliary view and the revolved projection technique. Here, stick with the edge view. That's the way we've been doing it. That's the auxiliary view method. They do have right below that in figure 15.9 what's called the cutting plane method. That's another way to project this. Again, we're not going to go into that one because it doesn't match up with orthographic. So stick with these edge views as you're looking through the text. All right, so let's start with sheet 11. So you have two figures here. The big thing I want to point out is when you're doing these figures, what you're doing here is establishing visibility. So we've got, on the left, you have a front and top drawing. Keep in mind there is a projection plane in between those. So if you would, line yourself up with the edge of the page with the triangle, but use the border to keep yourself straight. And draw that viewing plane in. Between those objects so that you can then project correctly. Okay? Because you want to stay real straight with these things. Focus on the center line. Whenever we're dealing with pipes, we never project from the edge of a pipe because it's a round surface and we don't have really a datum on them. Go to the center lines whenever you're dealing with pipes. Okay? We draw them off the center line. Same with roads. We always do center lines. We never do edge of road or any of those. So what you want to do is do that full line in between and then make sure you stay perpendicular to that and project these different ones up. So like in this case, I'll look at the front view. Is it AB or CD on top? I want to stay perpendicular and project up. Now I think you can see on this pretty straightforward. I hit CD first on this bottom view. So what does that tell me? It tells me that CD goes over the top of this, so it should be done with object lines. Type AD has to go underneath. So that one's going to come over, and it's then going to go hidden underneath it. Like such. So you would just draw those in. You're establishing visibility in each view. So hopefully you don't get this lower part wrong. Okay, so then again, establish it in the top view. Now, when you come to the one on the right, I'll wait just a moment. Looks like everybody's got their head down. Okay, on the one on the right, again, you've got a front and top view. This time they've brought another pipe into the deal. You're going to have to look at each point of intersection. So when you're doing this, the front view down here, okay, look at where AD and EF cross, project that up and establish which one's on top. Then go to the intersection of EF and DC. Project that one up and figure out which one's going on there. And then the last intersection is AB and CD. You want to do all three of them. And then you'll see how these are all laying in there. Remember, if you project one up and you hit another intersection, they intersect at that point. But stay straight. You stay straight, because you get a little crooked and you say, oh, I'm hitting that intersection, but your line's crooked, your projection line. No, they don't fit. You're giving out bad information. So stay straight on it. All right, that ought to be enough for that. The very first sheet, let's go there next. So when you're doing a plane, I'm going to read the instructions. Find a point where line XY pierces plane ABCD. Locate the point in all views, establish visibility in the two views. Now, here we have a plane and a pipe. These three lines right here, by the way, they're just to keep you straight. They're not part of the plane. You're dealing with plane ABCD, just this shape right here, and pipe XY. That's it. So just ignore these three lines. Again, you're given a front and a top view. Now, how do you want to project this and establish pierce points and visibility? Well, you can use the example in the text, which is figure 15.8. That will give you the information you need for this. Or, I went and drew up one where I did two planes. So you'd have another example, because your author really doesn't give you one of these. And I put the process on the bottom. This is just for your own notes. So in essence, when you are doing this is up two planes and how they intersect. Always first locate the true length line on one plane. Then project to edge view, or you're applying laws 1 and 2. Now, once you get to edge view of a plane, now you know where things are hitting, because we have visibility that we can then project back through. Okay. So first we got to get a plane on edge, then we start setting visibility. Okay. So in essence, just let me run you through the process here on it that I did on the figures above. And you'll follow the same process. Okay, now this one's got two planes. So there's a strike line on this drawing that never came up very well. It goes from A over to where it intersects CD. That strike line was then projected up to here. That gave this angle for this rotation. So there's a true length line on plane ABCD. It goes over, we see plane ABCD on edge. Now, if these planes are going to intersect, they have to intersect between here and here. They have to, because I'm seeing this plane on edge. Now, do they intersect? Maybe, maybe not. Maybe one's clear back behind it, maybe one's still in front of it. Then you start doing visibility. So I take this edge point right here. I said, well, if they're going to intersect, it's going to be right on this. Isn't this two lines? Line 2, 3, and line BD? Isn't that the same thing you just did with the piping? It's just two lines. Now, instead of pipes, they're just edges of planes. So then I take that point and I project it back. Okay. Now, if I hit inside plane 1, 2, 3, 4, the intersect's going to intersect right here. Since I'm inside of it, it is going to hit here. Then I take the other side, project it back. If it hits, it's going to hit right here. So that gives me this area. Now, notice the line goes on that angle, but we get outside the plane right here. Okay? I'm leaving plane ABCD, so it can't intersect outside of here. That's why I know this plane intersects just like that. And in essence, I also know, because I look at it, this is BD or 1-4. I project it back. Which one do I hit first? I hit 1-4 first. Therefore, 1-4 is on top in this view. And I can start projecting that around and see how things fit. Now, once I get that, I then project it down into the front view, and again, I'm just looking at these individual points. So I'm looking at AB and 2, 3, project that down, tells me 2, 3 is on top. So I start establishing the geometric location or depth of these items, and then I can sketch in the physical interaction of these two planes. Does that kind of make sense? It's all the same stuff we've been doing for a week, week and a half. But now we're just applying it to make these drawings a little clearer. Okay, so I just wanted to give that to you. Let's go back to your first one. Okay, so what do you need to do here? What's your first step? We've got a fold line in between, so we're going to draw a fold line. What's my second step going to be? Whenever you're dealing with planes, what do you need to do? You got to get that plane on edge. Okay. So you need to do a rotation and see plane A, B, C, D on edge, whichever one you rotate off of. So first do your strike line, get a true length line on it, then apply Law 2, project perpendicular to that, and that should put plane A, B, C, D on edge. Bring the pipe with you. Okay, what you're going to end up with, let's say I come off the top view. Okay? So there's my fold line. I come in here, and I'm going to draw this parallel. Let's say it's something like this. This is my strike line. I'm going to project that up here. Okay? And let's see, it hits CB, right? So let's say it hits right there. So there's this line. This line is true length. Okay? Applying the strike line. Then what am I going to do? I'm going to project perpendicular to that line. Okay? Where that is 90 degrees. Now, I'm not sure exactly how this looks, but what you're going to end up with here is you're going to end up with a line that looks something like this, where I have B, A, C, and D, something like that. And I should see it on edge. I'm also going to have XY. So it looks like XY does something like this. Y, X. In essence, you're done projecting. Now you just need to